You have probably heard by now that the simplest way to break into the IT world is by becoming a QA tester or perhaps a front-end developer. Today we're going to dive into the fascinating world of front-end developers. Who are they? What do they do? What do they need to know? And why do they only have to center a div to earn thousands of dollars every month? Well, at least until AI takes all our jobs. And while front-end developers, to be honest with you, are very well paid in many parts of the world, this demand is due to the constant need to create attractive web interfaces, intuitive and efficient ones that improve the user experience. Also, at the end of the video, I'll give you a great tip so you can be the ultimate front-end dev who stands out from the rest. This advice is going to be very important because it could be the difference between landing a great job or not. But anyway, let's start at the very beginning. What exactly does front-end mean? Well, it's simple. Applications and websites are logically divided into two main parts. The first part is the front end. That part you see and interact with on a website or application where you click on buttons and admire the visual design so that those clicks do more than just look pretty. Requests are sent to a server that, after working quite hard to process your difficult request, performs certain actions. This server is the part we call the backend, a complex, dark, and not very friendly universe where backend developers live. They are the ones who write the code that brings life to the logic behind everything you don't see. So we have two worlds, the client and the server, the backend and the front end. The client is usually a web browser. It requests and displays data. The server, on the other hand, is what actually processes all this data. The front-end developer's job is to write the code that lives in your browser and communicates with the backend. I'll give you a clear example. While you're watching this video on YouTube, everything you see is the work of front-end developers. The video player, the recommendation images, the titles, buttons, menus, and even the different types of fonts. All of this was created by the front ends. Now, let's do a little experiment. Press the subscribe button and then the like button. After doing that, at that very moment, your browser sends a request to YouTube's servers to add my channel to your subscription list, and then it receives a response. This is where the front-end developer's code comes into play once again. Your browser receives that response, and like magic, it changes the subscription button color and shows a nice animation. Try it out, you'll see it works. Now you might wonder, what if I'm using a mobile app? Is that also the job of front-end developers? Well, not exactly, or at least not in most cases. Front-end developers mainly focus on the web, mobile apps, while also clients usually require different technologies and are generally built by a separate team. Anyway, that's a topic for another video. If you're interested, let me know in the comments below. Now let's look at what supports this wonderful world. The three pillars: HTML, CSS, and JavaScript. What does HTML stand for? It allows us to structure the web page into logical blocks. Using YouTube as an example, we first have the header, then some videos. And finally, there's usually a footer with some social media links, useful resources, or that famous copyright notice that everyone ignores. Of course, YouTube might not be the best example for that last part, but I can show you a site with this exact structure on screen. HTML tells the browser how and where to display elements on a web page, using what we call tags. Right after the tag is where we write the text. This helps us understand where the content blocks begin and end. We can also nest tags, for example, when we want to include a link in our text, we use the A tag, which in turn contains a ref. But what is that ref inside the tag? That, friends of the channel, is what we call an attribute. Attributes provide additional information on how the element should be processed. Attributes are placed inside the tag and have a name and a value. For example, when inserting an image, we need to specify where to get it from. As you'll notice, my dear subscriber, and I hope you are one, some elements like this IMG don't have a closing tag because you can't add content inside. In those cases, we just need a self-closing tag, so to speak. There's a wide variety of tags, so let's take a look at a few more. HTML documents also usually have a hierarchical structure, starting with the HTML tag that contains everything else. Then comes the head tag, where we specify metadata that isn't shown on the page but is necessary, especially for SEO. like the title shown by the browser, descriptions, meta tags, Google indexing, and so on and so forth. Then we have the body tag, where we place the content. Another very popular tag is the div, which doesn't do much on its own, but acts as a container to group and structure elements within the web page, which we'll see later on. But if you've ever searched for how to center a div, then leave a like on this video. A very basic HTML page looks like this, but how does all of this actually look? Just save the text in an HTML file and open it with your favorite browser. It will interpret everything we wrote and transform it into something visually appealing. Well, maybe not in this example, but you get the point, right? Impressive, isn't it? But anyway, web pages haven't looked like this example for over 30 years now. Now everything looks spectacular, beautiful, and animated. Even impressive with animations that seem out of this world. That's because we're now entering the second part, styles, or CSS. So, what is CSS? Wait, don't be scared. It's simply a design language used to make our HTML page look beautiful. CSS specifies how elements should look. Colors, fonts, sizes, how they are positioned relative to each other, and other visual properties, even complex animations. How does it work? Well, I'll start by saying there are 3 ways to apply styles. The first is the inline method, where we write directly in the HTML tag to say exactly what we want and how we want to style it. If we want red text on a green background because we clearly have an exquisite sense of design, we write the style attribute inside the tag with color and background properties. But this method is impractical because it only affects one element, takes up a lot of space, and is very hard to maintain or for other developers to read. So we can use a style tag inside the head to write the styles. Or even better, standardize it in a separate file and link it to our HTML using the link tag. That way, when the page loads, the file is downloaded and the styles are applied. When we write styles externally, we use selectors to identify which element the styles apply to. Inside the brackets, we write the properties for that element. This is called a style rule. Here we can say that for all p tags, we set a font size of 40 pixels. We can apply multiple styles in a single rule to make everything look spectacular. But what if we don't want every element of a certain type to have the same style? That's where classes come in. It works like this. If we want several text blocks to share a style, we assign the class attribute with the same name in the HTML. Then in the CSS, we reference the class name by preceding it with a dot. This way, the second and last paragraphs can have distinct styles and colors, while the others do not. And if we need to style a single unique element, we use the ID attribute instead of a class. And in the CSS, we use a hash instead of a dot. Now, this can vary later on. Even though it might seem simple, CSS is a powerful tool for styling absolutely everything. We have the cascade where rules can be inherited and overwritten by more specific rules that take precedence over general ones. We also have pseudo-selectors for complex rules and media queries, which are critical for mobile versions of websites, allowing different rules based on screen size. CSS also allows us to create attractive animations with keyframes and add logic to our styles using variables. So that's a quick summary. Everything is nice and organized, but let's move on to the most exciting part. JavaScript. JavaScript was created to add interactivity to web pages. What does this mean? Well, JavaScript lets you react to user events on the page, like clicks, hovering, pressing keys, submitting forms, and many other options. Too many to fit into one video. It's thanks to JavaScript that things work. Sliders, complex menus, and interactive forms, pop-up windows that appear, error messages, or notifications that everything went well, and so on. Additionally, JavaScript can change the content and structure of the web page, continuously allowing you to add, modify, and delete elements based on their attributes and styles. In other words, you can redraw the page on the fly as many times as you want. For example, imagine a to-do list page. When you add something new, JavaScript lets you draw a new item in the list without needing to reload the page. One crucial aspect is the ability to send requests to remote servers. as well as downloading and uploading files, which is much less flexible and convenient without JavaScript. Now let's talk about the language itself. A common question that many people ask is, what is the relationship between JavaScript and Java? Actually, none. Back in 1995, when JavaScript was first created, Java was extremely popular. So the creators thought it would be a smart move to leverage that fame and include it in the name. JavaScript runs on the client side, meaning directly in the browser, and all other modern browsers fully support it. Of course, since it's so ubiquitous. It now also works on the server side thanks to some pretty magical developments. But anyway, that's a topic for another video. You might be wondering, how do I actually incorporate it into my page? You have two options. Just like with CSS, you can create a script tag and write your code right there. Or write your code in a separate file and link it with the script tag by specifying the file path. Let's see this in action real quick. First, we add a button using the button tag and assign it a unique ID, which is something we already know how to do, right? Then, in the script block, we create a variable using the let keyword and assign it the HTML element we found using the ID we gave the button. Yes, we can find it that way, though classes or any other attribute also work to reference it, but it's common practice to start by using the ID. Next, we create what's called an event, which triggers whenever the button is clicked. Then we link this click through the variable, so when someone presses the button, the function we wrote inside will execute. In this case, a modal window will appear saying, button pressed, and here's the trick. You can insert the JavaScript code directly into the HTML. This means the browser parses and executes the code line by line without needing to compile the entire thing beforehand. This is something I've explained quite thoroughly in a video that you can watch right after this one, and I highly recommend it. It's called How Computers Understand the Code We Write as verbs. I will leave a link for you in a YouTube card or directly in the description. However, to optimize and boost overall performance, modern browsers use something called just-in-time compilation. In this case, parts of the code that run frequently are converted into machine code, which is then executed directly by the computer's processor. Additionally, JavaScript can work asynchronously, for example, when we've sent a request to the server and are waiting for a response. Meanwhile, the code keeps running without any interruptions until the response is ready. It's also worth mentioning that JavaScript is a dynamically typed language. This works just like in Python. You can create a variable, assign it a number, then change it to a string, and no one will stop you. Everything is great because there's no strict control. You can do amazing things like adding strings to numbers and so much more. Yes, it's total chaos that some see as magic while others see as a problem. But this also requires attention, because it can lead to very strange behavior in your code, as well as errors or bugs that happen quite often. Additionally, JavaScript is an object-oriented language. Well, this is a way of writing code by grouping certain blocks into separate entities with unique properties. But to understand it better, you can take a look at another video I have explaining what object-oriented programming is all about. But now for a totally unexpected twist with JavaScript, you can also write back-end code very easily. You can go from being a front-end developer to a full-stack developer. All of this is thanks to something called Node.js. But how does it work? Well, all browsers have a code interpreter, also known as an engine. This engine reads the code you've written and converts it into commands the computer can understand, allowing the browser to execute what you want. And what prevents that code from running on a server? The fact that it's not a web page or a browser. So what does it work with? Imagine you've written a simple application in JavaScript that tells the user which Hokage they are. Wow, Naruto, what's more exciting? Anyway, this tool that identifies the Hokage only works in the user's browser when they visit your site. They'd log in and find out they are 80% Kakashi and 20% Hiruzen. But what if you want to send the results to their email, or let's say, to Telegram? Then your application needs to be able to interact with a database to register the email or call the Telegram API. And that's already back-end logic, right? So you're faced with a problem or a choice. Rewrite your application in another programming language or use Node.js. Move your JavaScript code there and add the necessary logic. Easy. In essence, Node.js is an application that runs on Chrome's V8 engine. It takes your code and executes it, but all on the server side. It's a very useful tool and, well, Let me know in the comments if you want another video about Node.js, though I already have quite a few in my playlists. But without getting too sidetracked, you might be surprised to learn that you can also build desktop and mobile apps using JavaScript. For the former, the most popular way is using the Electron framework, which has been used to create many applications. With Electron, you write HTML, CSS, and JavaScript code, which then runs in an app using the Chromium engine, which, by the way, is what Chrome and other browsers are based on, except for Firefox and Safari and, well, a few other rare ones. Plus, you have all the capabilities of Node.js, like system file access, something that isn't available in mobile browsers. There are also many options like React Native or Flutter. Well, although Flutter isn't made in JavaScript, it uses a different language. Anyway, it seems the time has come to talk about JavaScript frameworks. It's incredible how many there are, appearing so frequently, and they're all so attractive, innovative that they've become a meme themselves. A JavaScript framework is a set of libraries, tools, and structures that greatly facilitate and improve efficiency in app development. In JavaScript, they've become so essential to the front-end ecosystem that many projects are no longer written in pure JavaScript. To keep you from going crazy, let's quickly review the most popular ones before a new one pops up and completely changes the game. As it is every week, the big ruler here is React. And the funny thing is that it's not a framework, but a library, though that doesn't make it any less popular. And well, many people refer to it as a framework, but I don't know what you might think. React is widely used for creating SPAs and progressive web apps, the beauty of which is that they are pages that feel like normal applications. All changes happen on a single page without reloading over and over to wait for new updates. This is possible because React is based on components, allowing you to split the interface into small, reusable parts that implement specific logic, greatly simplifying development. And here again, we have declarative programming, where we decide what we want to do, not how we're going to do it. React will automatically update and render the components whenever the user interacts with them. It's an impressive tool that I've been using for several years now, and I'll be making a special video about it. I also plan to upload a free course here on YouTube, so don't forget to subscribe to the channel. And I'll also mention other popular frameworks in the top 3, like Angular, Vue, and Svelte, and other innovators like Astro, for example. Are you tired of so much content? Don't worry, I just want to mention one more thing before giving you the ultimate tip to stand out as a front-end developer, meaning you'll be able to pass any interview even when competing with people at your same skill level. Before that, let's talk about something called TypeScript. It's a programming language that extends JavaScript, is compatible with it, and compiles into it. It was created to increase reliability thanks to extra features like static typing, classes, interfaces, modules, and other very interesting terms. So, if you feel like you're running out of room in JavaScript, you should definitely take a look at TypeScript. And well, regarding TypeScript, I have another video on the channel that you might find interesting. Before we finish, I'm going to give you a recommendation you must learn if you want to stand out as a front-end dev. As I said at the start of the video, this is about learning software architecture specifically for UI development, such as atomic design, which helps developers build consistent and solid user interfaces across their projects. It's based on the idea that, just like in chemistry, everything is made of fundamental elements. In the context of web design, these fundamental elements are atoms, molecules, organisms, templates, and pages. By understanding and applying this structure, you can create more efficient, reusable, and scalable user interfaces. Besides atomic design, which is just one example, it's one of the most used and requested in the job market. In addition to this, it's vital to stay updated on other methodologies and tools that complement this architecture, like BEM, for naming conventions or material design, or Ant design and design tools like Storybook and Figma that allow you to build and test your UI components in total isolation. I'm telling you, just by knowing a bit of atomic design, you'll impress any interviewer, especially if you can apply it and defend it. There are many other things to consider regarding web architecture, but as a beginner, you shouldn't worry too much. To finish, I'll leave you with a question. We said React is a library. What's the difference between libraries and frameworks? And remember, every time you like, subscribe, and hit the bell, You make this developer happy and motivate me to keep bringing you all this type of content. Thanks for watching this far. See you next time.